I will be today, a little bit the moderator from this conference. Urban Circular Bioeconomy, Valorising Biowaste, Creating Prosperity. And we will have first a welcome note from Marie-Carmen. There was a short change because our director, Nerea Briz, for some health problems couldn't come this morning. So Marie-Carmen was taking this. She is the director of the business unit, of the food and health area of Tecnalia, and she will give us a short welcome note. Thanks.
Gracias, Tomás. Bueno, transmitiros en primer lugar las disculpas de nuestra directora de la unidad, Nerea Briz, que por problemas de salud no ha podido venir, pero bueno, nos ha dejado escrito las ideas que quería transmitir y que espero reflejar fielmente. Buenos días, bienvenidos a la conferencia de Bioeconomía Urbana Circular, valorizando bioresiduos, creando prosperidad. Lo primero, agradeceros vuestra asistencia a esta conferencia, cuyo objetivo es trabajar en cuestiones como ¿por qué los bioresiduos urbanos siguen siendo residuos? ¿Qué estamos haciendo con nuestros bioresiduos? ¿Cómo pueden los bioresiduos aportarnos un valor adicional? Esta conferencia se enmarca dentro del proyecto CAFIPLA, que se basa en la combinación de la producción de ácido carboxílico y la recuperación de fibras como un proceso de pretratamiento innovador, rentable y sostenible para bioresiduos heterogéneos. Por tanto, agradecer a los miembros de este consorcio la organización de este evento y el trabajo realizado en el proyecto. Los ponentes, expertos en bioeconomía para la industria y la investigación, nos van a proporcionar información sobre biorefinería, disponibilidad de materias primas, aspectos tecnológicos de la plataforma combinada, vías de fermentación para transformar estos ácidos carboxílicos de cadena corta en compuestos de valor añadido, apoyando así a la implementación de una bioeconomía circular basada en bioresiduos. Asimismo, agradecer a los participantes de la mesa redonda, Marie-Aline Pierrat de Indeluz, Martín Soriano de Cetenma y Bruno Ferreira, CEO de la empresa Biotren. Esta conferencia se organiza en Vitoria-Gasteiz por su apuesta por la transición verde, que le hizo ser seleccionada Capital Verde Europea. Esta ciudad trabaja de manera continua en la mejora de la recogida selectiva de los residuos municipales, incluidos los bioresiduos. Joseba Sánchez, del Ayuntamiento de Vitoria-Gasteiz, nos presentará con su ponencia los logros alcanzados y las estrategias implementadas en la capital, los avances que esta ciudad está realizando en esta línea. Como es bien sabido, el uso de los residuos petroquímicos, de los recursos petroquímicos contribuye a las emisiones de gases de efecto invernadero y al cambio climático y, por tanto, afecta negativamente a nuestra salud y a nuestro ambiente. Se lleva tiempo desarrollando nuevas estrategias para cambiar nuestras economías hacia el uso de materias primas renovables. Sin embargo, un informe del uso de la biomasa en la Unión Europea nos indica que en las condiciones actuales existe una brecha entre el 40 y el 70% entre la oferta y demanda de biomasa. Por tanto, los residuos de biomasa disponibles, incluidos los bioresiduos, deben utilizarse de manera sostenible, centrándonos en estrategias de reciclaje ascendente para transformar estos recursos de biomasa en productos de base biológica de valor añadido y para mejorar los aspectos de circularidad de la biomasa. En este contexto, la Comisión Europea ya estableció en el año 2018, en su estrategia de bioeconomía, que las ciudades deberían convertirse en importantes centros de bioeconomía circular. En esta transformación, uno de los principales retos de la valorización de los bioresiduos municipales es la valorización de los residuos municipales debido a su composición heterogénea. Por tanto, esta conferencia de hoy proporcionará una respuesta a preguntas abiertas relacionadas con la valorización de los bioresiduos heterogéneos que se generan en los centros urbanos y los enfoques tecnológicos a utilizar para lograr un beneficio a partir de ellos. Comenzaremos la jornada con la ponencia de Joseba Sánchez sobre las estrategias de bioeconomía a nivel local en Vitoria-Gasteiz. Posteriormente, los socios del proyecto, CAFIPLA, van a ir presentándonos los extraordinarios resultados conseguidos en el proyecto y que les han llevado a conseguir una planta piloto con capacidad para tratar alrededor de 6,25 toneladas al mes. Han llegado a un TRL5 implementando en la instalación el tratamiento de los residuos en las plantas de Idelus en Bélgica. Asimismo, Martín Soriano de Cetelma nos presentará la perspectiva a nivel europeo y los retos que se plantean para llegar a establecer estos sistemas de circularidad con los biorresiduos en las capitales. Concluiremos con una mesa redonda para debatir las cuestiones más relevantes. Y sin más preámbulos, doy paso ya a Joseba Sánchez y espero que disfrutéis de la jornada de hoy. Muchas gracias.
La próxima presentación va a ser de Joseba Sánchez. He holds an engineering degree from the ETSE in Bilbao. And he is, that's the most important thing, he's the head of the environmental services of the whole town. I'm living in Vitoria, so I know very well the good things which are done by this department. Okay,
well, thank you very much. Well, first of all, I'll try to put Vitoria in the map. I think that most of you live here in Vitoria, so probably you will know where we are, but for those of you who are from outside, just to know where we are and how big we are a small city, 240,000 more or less inhabitants, but it's quite wide. And I will say that we have a municipal waste budget which could look high, but it's not. If we would compare it with other cities close to here, we could say that it's not a very high budget. As they said, we've been a European Green Capital in 2012 and a Global Green City Award in 2019. 2012, it's a long time ago, since 2012. As you all know, the Green Capital is not a prize about waste management or circular economy. It has a lot more aspects that are important. In fact, there are 7 aspects which are important and evaluated. Waste is just one of them. In 2012, Vitoria had a very high punctuation regarding to waste collection. It was a very good system in 2012. Nowadays, we could say that we are a bit far from where we should be. We haven't gone with the high speed that we should have gone, and that's one of our goals for the future, as I'll explain you later. And of course, our main goal is the collection of organics. Here we have some collection data. As you can say, well, these are data from 2021. We do have the data from 2022, but they are not still public, so this is why this is 2021. As you can see, we are here, and you can say that we have a selective rate collection of about 36%. It's not a good rate. It's not a good rate. Europe asked us to be, today we should be in 50%, at least in a 50%, and we are far from this rate. It's not, I've said that we are far, but anyway, I will say that it's not a bad rate. Why it's not? Because we have 24 hours, 7 days a week, open container in the street, every day. So, I mean, it's recycling is just a matter of voluntarity. If they want to recycle, they do. If they don't want to recycle, they don't. We've seen that in Spain, with this kind of models that we have here in Vitoria right now, this is the highest rate that we can reach. If we want to go further, if we want to reach this 50%, if we want to reach more that are asking Europe for the next years, we have to do changes here in Vitoria. We have to close containers, we have to make some door-to-door collections, we have to change our system. With this open 24 hours container system, we are not bad. That's the truth. So we'll change it in the future. What are we doing right now? Well, this is our photography. I want you to notice two or three things here in our photography, in today's photography. As you can see, we are collecting just a 6% of organics. I think it's over there. I don't know if this works. I don't know. Well, it's okay. As you can see in the upper part, we are collecting just a 6% of organics. It's quite low. We have to increase it a lot. This is one of the main problems we have here in Vitoria. We also have some other problems. You can notice, well, in the lower part, you see what we are spilling in the landfill. We are spilling 53% of our wastage in a landfill. I will explain later how we are doing this and how it finishes there, but it's quite a lot. And also we are creating just 5% of compost. And this 5% of compost used to be a very high quality, and nowadays it's not that good quality. I will explain why. But this is today's photography, and we have to change this photography for the future, for the near future, okay? Here we have a slide of how we've gone with collecting organics, okay? We made a step in 2012 with our first containers in the street. They were open containers, orange containers, open, 24 hours, open containers. So we made the jump in 2014, as you can say, and we've been going up, but not at the speed we would like to go. And the problem is not that if we are collecting a lot or not. The problem is that the improper has been increasing a lot here in Vitoria. That's the main problem we've seen with the organics. So we have changed our model, okay? These open containers, these orange open containers are just the past. We are introducing our new containers, which are bigger, which has a lock, and which has an identification. Why? A lot of people in Vitoria doesn't understand why we have done this change. I know it's new for Vitoria, because we've never done that before, but in Europe, it's quite normal to see these things. Not only in Europe. If you go to Catalonia, if you go to some other places here in the Basque Country, you will see this kind of containers and this kind of systems. People in Vitoria are reacting, some good, some others not that good, to this lock and to this identification, but it's absolutely necessary. We have to decrease the improper. It's very important for us to decrease the improper to get a good quality compost, because if not, we are not going to get a good quality compost. And of course, there's another thing that is very important for us, which is the fiscality with all this. If we want people to recycle, we do have to have a different fiscality that we have today. Today, everyone pays the same here in Vitoria. Doesn't matter if you recycle or not. Doesn't matter, and that's not fair. We have to make people who are recycling to pay less than people who are not recycling. And the only way that we can know if they are recycling or not is just with an identification, okay? So that's the main problem that we are solving right now and that we are implementing here in Vitoria. The first results are being very good. I mean, they are preliminary. We haven't finished all the implementation, so we have to wait, please, a bit. But the improper has decreased very significantly, from the 30% that we had with the open containers to a 4%. And that's, I think that we still can decrease that, but that's a good point. And of course, the goal is to increase the amount of waste collected. We are collecting more or less the same amount that we were collecting before, which is, for me at least, a good notice, because if we have less improper and we have the more or less the same amount of waste collected, well, it's not that bad. But anyway, we have to increase a lot the amount of waste collected. We have some other models here in Vitoria that we have implemented, the community composting. We have 5 spots here in Vitoria with this kind of compostings, and they are working really good. In Salburua, it's working great. In Goicolarra also is working great, and we think that this is a good model for us, and we will put more spots in the future, in the near future. So we collect the organics and we send them to a mechanical biological treatment plant. What do we do there? Well, we are treating more or less 71,000 tons a year. And we are separating, we are sorting there some plastics, cardboard, and so on, which is about 4,000 tons. But for us, the most important thing is that we are valorizing the 53% of the waste that we are sending there. What does that mean? That means that if 100 tons gets in this treatment plant, just the 53% of them go to the landfill. And that's our goal. That's what we have to change in the near future, okay? We also have biomethanization there for the organic waste with Dranco. I think Dranco is over here today. So it's a technology that is working really good for us. We started with it in 2006, and we have to say that it has worked like a clock. It didn't have any kind of interruption in all these years, and we are treating just 20,000 tons a year of organics, because this is the highest amount of organics that we can treat in this, with this system. And we are generating a lot of energy. I don't want to talk about numbers, but I want to say that our treatment plant doesn't need energy from the outside, okay? All the energy he needs, we take it from the biomethanization that we do here, okay? So this is the actual situation. We are treating all the organics before spilling in the landfill. We are generating compost and electricity from our organics. We are collecting separately approximately 36, 37 of our total wastes, and we are spilling in landfill in approximately 53% of our wastes. As I said, I wouldn't say that they are bad numbers, but I will say that they are not enough, not at all. We have to increase them a lot, okay? So we have some projects in the near future to change this in the next 2-3 years. Which are our challenges? Well, as I said, the first and most important thing is the rejection of the TMB plant, okay? This 53% that is going out from the TMB plant. With the Diputación Foral de Álava, we have a project which is going to give birth next year to do a bio-drying plant. Why? Because this rejection that we are sending to the landfill is still a bit wet, so we have to dry it in order to sort all the things that are in this rejection. And we have 2 projects going on. The first one is called High Value with Novargi, and it's going to transform this rejection in hydrogen for the Basque corridor, for the Basque hydrogen corridor. Okay, this is a project which is going on. It has just a budget, a place where it's going to be. So we are proud with this project, and we hope to be watching it in the near future. We have some other projects, but they still don't have this budget approved, so I won't talk about them. But we have some other projects so that we are not going to send this 53% to the landfill, and we are going to change all these numbers, okay? And regarding to organics, as I said, what we want to do is to increase the amount of organics that we want to collect. With this increase, what we will need in the near future is a new composting plant. This also have a budget and a place here in Vitoria, in Jundiz, to be. So we hope that in the next 1-2 years we'll have a new composting plant, and we'll do a high quality compost coming out from this plant. And I know it's not regarding to organics, but just to circular economy. So I want to notice just very quickly a pair of projects that we have that we are running in the last couple of months. The new contract that we have for bulky and the new Reutilizagune. If you live in Vitoria, you've seen that this has just been about a pair of months from here. So these are 2 projects. The bulky treatment, we are collecting our bulkies, we are sending it to a sorting plant, and we are putting it back in a shop which is in the city center in Canciller Ayala Street, and it's working really good. We are very proud of this project. We also have the Reutilizagune. Reutilizagune is an installation for reusing, and we have changed the model that we have for reusing. Till this year, everyone could go to Reutilizagune, which was in an industrial spot here in Vitoria, and it was free. You could go there and take whatever you wanted and take it to home. We've changed that, okay? Now it's not free anymore. You go there, all the things have a value, and we want to give a value to all the things that we can reuse. But we don't want this value to go to the city hall. So what we do there is you go there, you take, for example, a bicycle or a computer, whatever you want, and when you take this bike, you have to pay an amount, but not to the city hall, but to some solidarity projects, which you can choose when you go there. So we are proud also with this project. I know it's not regarding to organics, but just to circular economy, so I think it's important to notice them. And that's all. Thank you for your attention, and if you have any question, thank you.
Any questions for Joseba? Thank you very much for the presentation. Also, first of all, I live in Vitoria, but not all of the projects I know. But I can tell you already the new system with the separation of the bio-waste at home, we are separating now significantly better, and the part which is really waste, also waste, has reduced significantly. Also, thank you very much. Thank you very much. Yeah. Then we will have now the presentation from Susanne Günther. Susanne is, has a master degree in geography, and she is an expert in geographical information systems, and she makes analysis of spatial distribution of biomass, biogenic resources, stakeholders which are involved in this. This is normally the first step in the bioeconomy to analyze this. And Susanne, please take.
Thank you. Hello, welcome from my side as well. The pointer's there. So I'm gonna tell you a bit today about our project Cafiple, but also how we mapped the biogenic resources in Cafiple, and then how we went on to map them on a European scale. But first of all, I would like to put in place Cafiple a little bit, because I realized we don't really have a good overview where the project took place. So it actually took place in the south of Belgium, in Wallonia, in a very rural area. So yeah, it was a bit harder to find certain resources there, because there's not many industry, there's like not too many people, the collection system. Has to travel quite a lot to collect all the different bio-waste. And so, yeah, we had quite some challenges, which I will then go back in the end of my demonstration and see what limitations we face in Cafiple, but also on the higher scale in Europe. So, is this working? No? There, yes. So mapping biogenic resource potentials across Europe. How do we get from Cafiple to European scale? So first of all, as I said, let's have a look into the Cafiple nutshell. What needs do we have there? What availabilities do we have? And then how do we get from local to a continent scale? We will have a look on the European data. And then I would like to give you a glimpse of our new European Potential Atlas, which is just out now, or the beta version is out now. And I'm happily showing you and get some feedback maybe from you also, to show you how or where is European biomass available. And then we also realized that it's not about the availability only, it's also about how we do mobilize these resources. So let's jump here. What did we do in Cafiple? In the first step, we checked actually what residues, bio-waste, or like waste in general, byproducts do we have. And therefore, we used mainly our resource database we developed over time at the German Biomass Research Center, where I'm working. And we discussed all of this with our partners. So it was very important to understand, are these resources, or which resource of this table are technically applicable to our Cafibla technology? Then are they legally also applicable to use them? And are they compliant with the end-of-waste criteria of the European law? And then also our partners took some lab tests and sampled, and in the end we came up with these 3 different categories of waste which are suitable for our Cafibla plant. So the most important is the municipal waste. Like more than 80% from the municipal biogenic waste is going into the Cafibla technology, or into the loop, as we call it. You will see a picture later. And then there's some other residues we can fill up our technology depending on what we have, what are, for example, the prices, the seasonality. And these are agricultural byproducts as well as industrial residues. And so the main aim in Cafibla we had was to make a resource screening around the pilot plant. We took here a 50-kilometer distance measuring, and only in Belgium, because we also, in this area, we are bordering Luxembourg and Germany. So we focus mainly on Belgium for the moment. And here are some results. So for the biogenic municipal waste, or here you see basically the red dot is our pilot plant, and these are the 50 kilometers surrounding as a driving distance. And you see it's in Belgium, but we are bordering Luxembourg and France and Germany. So the red spots are high potential of biogenic waste, and green is very low. And if you're a bit familiar with the area, you also see the red dots are very highly correlated with the populated area. So of course, the more population we have, the higher is the biogenic waste. If we have a look into agricultural byproducts, here for example, maize stover, we see it's more directed to the northwest, where there's the agricultural production a bit more located. And yeah, the potential is not that high. But yeah, we don't have to drive to the south or to the east to find our resources. We know where we have to go. And for the industrial residues, it was a bit more difficult, because usually industrial residues are point sources, and it's companies, and usually data is confidential. So we mapped the companies, we tried to get in contact with them. Some we got good feedback, some others we did not get any feedback. But in general, we collected quite a well amount of residues for our pilot plant. But as I said, availability is not only the important thing. So here we see just the availability. It's also important to understand where's the seasonality. So for example, biogenic municipal waste comes very continuously, because it's like in the collection system of the city and it's regularly collected, but the storage time is very low. So you have to handle this kind of waste. Whereas for example, maize stover or agricultural products, byproducts in general, are very seasonable. And they come in a very high volume once the season is ready, but then they're quite well to storage. So if you have the capabilities to storage, it's nice. You can also always add if you have not enough other waste. But yeah, you have to keep that in mind. And for industrial residues, we found out, of course, they're very nice, because usually they're coming from food production. So they're very high in quality. And they're coming usually also quite in a stable flow. And as I showed, we have here the surroundings, and you see these little lines. These are 5-kilometer lines around the pilot plant. We then can also calculate how far we have to drive to collect a certain amount of residues. So we call these supply curves. And we see for our pilot plant, we didn't have to drive that far because it's very small. It just needs 10 tons of resources per year. But then you can calculate, okay, how big has to be my future plant? What can I fill? How much or how far I have to drive to collect a certain amount? And so, by the end of the project, we can say, yes, our pilot plant is running, and we have enough resources, and also to scale up the whole thing. But now the question is, how do we get from our nutshell on a European scale to understand, first of all, where do we have the resources we need for our technology, but also where can we go to transfer our ideas. And so we had to look first into European data, because now we need to understand what is available for biowaste, for agricultural byproducts, and also for industrial residues. And for the biogenic waste and also for the agricultural data, we found some quite good data from Eurostat. And for the industrial data, we had to look a bit more into reports, statistics, and it's a little bit more difficult. And this is all quality input data, usually on country level. And then to regionalize, we had to understand where are these resources located. So, as I said, for the biogenic waste, it's usually correlated to the population. So we use the population data then to scale it down to a local level. For the agricultural data, we use current land cover, which has different classification, also on a local level, so we could rescale this. And for the industrial residues, we had to do a little different approach because, as I said, most of the data is confidential. You don't know how much a production site is producing as like quantity of their products, but also as residues. So we had to map usually the production sites, but are not sure like about the quantities. So it's more approximation. And you will see two different output data. So in the end, we come up with time series, yearly time series of from country level to local level. So as you see, the biogenic municipal waste as well as the agricultural data, we have a very nice time series from 2010 to 2020 on all the different spatial levels from country to local. And I will show them in a second a little bit more in detail because these maps are very small, very static, and we go into a bit more dynamic version of them. And for the industrial residues, we basically just could map them on a country level for the whole time series, at least for the whole time series. So we see already trends, but we did not manage to localize them. So with the approximation, with the production sites, at least we could say in which regions they are located. And I also will show you in a second. And I also invite you to come to this webpage. This is our dashboard of the European Potential Atlas. You can scan the QR code or you just type in the webpage. And it's just a beta version, so it got online yesterday. There's still some bugs, but if you like happy, we are really happy for feedback as well to also increase and understand like what would be your needs to really find this a useful tool to then work with it, for example. So I also jump in here. I'm not sure if I do it or they do it. Okay. I don't do anything.
Can you show the website?
Yeah, actually, they told me I should do it, but I can't find it here.
Okay.
It was actually down there.
Where?
Ah, yeah. Can you go there?
This one.
No, to the Chrome. This one.
Thanks.
Yes, perfect. So now you see the entrance page. And you see our different resources with a drop-down menu. And for example, we can jump here into the biowaste. We can select either country level or we go down to like smaller scale. Yeah, we can zoom out to have a better understanding where we are, what are our regions, or we zoom in somehow. I go maybe, could be interesting to see 2021, but maybe I want to know what was the level in 2017, or as we said, like I want to see how it changed from 2010. We see like Spain, there's not much yet in bio-waste collection. And if we check 2020, well, there's still not that much, but here in France, there came a lot. And we can compare, for example, also regions. So I can select a region in France and northern Spain, and I want to see some details. So I get a nice overview, actually, how it developed over time. I can see my 2 regions. I can also collect more regions if I want to compare more regions. And I also can compare them on a European level. So I can see here what is the best region, or like the highest region, or the region with the highest value of biowaste. And where are my 2 regions here? So they are ranked in ranking number 18 and 65. And I can do this for a lot of different regions. For example, can always let me show, okay, how is it in Poland? And as I said, I wanted to show you also, for example, the industrial residues. So we have beet pulp from the sugar industry. And we see we can just understand them on the country level. But I see here, for example, in France, it's very nice. All the production sites are located in northern France. So I know if I want to work with industrial residues from the sugar industry, I have to go to the north of France. And then you have to do some more stakeholder engagement to understand how much is actually available and so on. So this is our freshly released tool. And now I want to jump back to the PowerPoint. Okay. And show you also the limitations we faced. So here you see our supply chain from the beginning to the pilot plant. And as I said, we had quite some difficulties to find good data and also enough data for the time series to see also the trends and to build up this kind of monitoring system. So this dashboard is also a kind of a monitoring system. But we had not just only the resource availability, we also wanted to understand how can we mobilize them and what is all needed to really mobilize the resources, but also to get the technology into the market. So we also had a work package on the stakeholder engagement, and we had some workshops, and the limitations we found were, for example, that for biowaste, there's still no real ISO standards. So the product development is a bit slow. Also, the EU legislation is not yet ready to really to valorize really biowaste. And the Kaffeeblatt technology needs to have some boost to really bring it into the market. So we're like one level, I would say, before the market uptake. So we need some investment here as well to upscale. And at the end of the supply chain, we also see that recycling and composting, especially from bioproducts or bioplastics, needs still some investigation to bring it back into the cycle as well. And the social acceptance, of course, to really use products coming from a waste. So there we need some more work to do, I would say. But we also saw that, for example, many startups are coming up now in this sector because the resource costs rose a lot in the last years. And so many companies see also that they can cut their production costs using, for example, waste. So this is a real thing. And also at the European level, there's a lot of financial incentives to push these technologies a bit forward. And there's a lot more to come. And especially on local level and regional level, as we also heard today, there's a lot of new ideas coming. And with this little market insight, I will hand over to my next speaker, she will also give you a better overview. First, Thomas, okay? And then Ilse, who will give you a better insight into the market uptake. Okay. Thank you.
Any questions for Susanne? If not, I made a small error, so for that reason, but in principle it's not so bad. Thanks, Susanne, for jumping in, because of course, first it was planned to have a very short overview about the Kaffeeblatt project itself, and then to go to the biomass. But however, so we spoke first about the biomass, which is evaluable. So as we have seen there, it's increasing the amount of biowaste which is coming. We are doing here in Vitoria the things to get more of it. And then what we can do with it. So I will give now fast the short overview about the Cafipla project, and then afterwards Esther will speak about the market aspects. Okay. Can you make my one? No, my one, the first one, the second. Exactly. So heterogeneous biowaste, a valuable resource. Also this is, yeah, to speak short introduction about the Cafipla project. Okay. As we have heard already, so we have to work more on separate collection of our different fractions and then to feed them back in our economy. Especially heterogeneous biowaste, especially as a municipal biowaste, which can have a lot of other compounds inside, which we don't want there, can be a little bit tricky to treat in a way that we are getting, for example, high-value compost or other compounds out of it. So that means this is a report from FAO about the value chain of food production. So that means, as we can see, the red ones, the red dots, this is the consumer. So a huge amount in the different value chains of food, comes on the consumer side. So we have to make an effort at industry level. There it's already established so that these side streams are collected and treated in a certain way. But especially on the consumer side, also we have to make more effort to get these residues back in a proper way to our economies. Because in the past, as we have also heard from Joseba before, they were going to landfill. In the landfill, under anaerobic conditions, they are producing methane. Methane is significantly more dangerous in terms of greenhouse gas potential than CO2. So that means we have to do all effort to avoid that these kind of materials are coming or going to the landfill. So therefore, the Commission established some objectives which should be reached. So therefore, we have to establish separate collection. Okay. So what was done or is done also in this directive, so on one side as landfilling is forbidden in theory, we have to reduce this amount going to the landfill. So one way is composting, as we have also seen, it can be done also on local or small level in the cities. Then this is only a fertilizer recovery in a certain way. Then it can be combined with anaerobic digestion, so then you are getting at least an energy recovery out of it. The main problem there is that to produce these biomass, because we have also to shift a little bit, it's not biowaste, it's biomass. We are using energy and fertilizers, producing in this also greenhouse gas emissions, so we should try to use this biomass when it's produced once in a way that it can be reused in our economy in a certain way. Especially as there's a new report from 2021 which comes to the conclusion that under net zero greenhouse gas emission in Europe, what is the plan, as we want to have to reduce our greenhouse gas emissions, we will have a gap of 40 to 70% of a valuable biomass. Also supply and demand are not going aligned. So that means we have really to look that the biomass we have to use in a proper way and in the best way possible. So there comes the question, or what could be done to, beside fertilizer and energy recovery, is there also an option to make a material upcycling? So there we were looking for certain partners with the same interests. So we are 12 partners from 6 countries, but the most important is there are people behind which are working in this project. And we are creating the Cafipla project, where we are trying to work with 2 platforms, as is the carboxylic acid platform, to convert the easy degradable organics. We will hear later a little bit more on that from Thomas Willems, into short-chain carboxylic acids. And on the other side, we have also lignocellulosic material, which can be recovered as fibers. So there we will follow 2 approaches, and we will hear later on something from Thibault and also from me again about this. So This is the general scheme. So Susanne was so nice already to speak about the first one on the left side. Also the logistic aspects are very, very important as to make it also economically feasible. The distance to the treatment plant are important. So that means we have to make a proper mapping of the resources available at a certain level. And then we will have presentations about the different aspects here, also the short-chain carboxylic acid platform, which is our Cafibla loop, how we call it. Then we can recover the remaining fiber part with natural depoytectic solvents. We make, on the logistics side, we are separating already in the incoming part. For example, green waste can be transformed very nicely. There you can see also later on in our exposition outside some examples. Thibault was bringing them. So they can be very nicely transformed, for example, in insulation material. And then we are also answering the chemical industry, also caproic acid can be used in the chemical industry. Microbial protein, as everybody knows, food feed security is also important, so we are analyzing if it could be also converted back in a food product or feed product. And then, of course, plastic. Everybody has already heard that we have problems plastic, so we are able to transform these biowaste in biopolymer PHBV, which can be used in plastic applications. Also there you will see later on outside bag made from from biowaste in a certain way. Okay, so that means this could be an answer. Why it's there in a row is it's not not the Cafibla will replace all the anaerobic digestion or the composting. In theory, it's foreseen to be an integrated part. So depending on your, as we saw already before, logistic aspects, it's on one side the biomass availability, but also the respective other companies which can use your output. So depending on the special location, residue streams, the Cafibla, can be still treated in anaerobic digestions, and the digestate can be treated in composting. So you are getting as a material upcycling, bioenergy, and fertilizer. So you're increasing the value of these bio-waste. So you can get fibers, short-chain carboxylic acids. We will have also a presentation from a previous project where we can get short single-cell oil for the oleochemical industry, which can be transformed, for example, in soap, so that we tested successfully. So you can transform bio-waste in a soap. Then we have a microbial protein presentation from Michael. Omega-3 fatty acids will be presented by Laura. Caproic acid will be done by Kevin and PHA by Anna, also the biopolymer PHBV, and also we have materials. Thibault will speak there quite in detail, and because they were speaking really to the industry and presented already results on there, as I understood that there's a huge interest from some industrial players to follow with these materials. So, yeah. Thanks again, Susanne, that you were jumping in, and there you can also see again the loop. Also, I was putting it with me inside because that you get an idea about the size. It's not lab scale. It's really semi-industrial pilot scale. Okay, then as we have heard now, biomass, the Cafibla concept. Esther will speak now about the market of these products. Also one thing is we can transform it, but exists there really a market for that? So Esther is working in Dechima, and she is doing, you have a bioprocess engineering background, and you are normally developing these exploitation strategies for different type of biomaterials,
sources.
Okay.
Thank you. Did he get an applause, actually? Yes, so thank you very much. My name is Esther Hegel, and I'm very pleased to be here today to talk about the work we've done at Dechima within the Cafibla project. And I have to mention that the work was not done by me alone, so there's Caroline and Christina who are also here today to contribute significantly to this work. So I'm very honored I can present it on behalf of all of us. And what I decided to do today is basically to focus on 3 main pieces of work we delivered within Cafépla, which are the 3 reports you see here. And they all focused on market impact and implementation. So the first report you see on the left side is called Initial Market Assessment Report, which was a very early report we finished in 2021. And the main part for today will be the final assessment report, which you see in the center. So we just finished it early this year. And the last concluding piece I want to briefly talk about is the implementation guideline, which was just finished 2 months ago. And good news is they're all available on our website for free to download. So my goal for today is basically to give you insights on what you can find there, and then you can download them yourself and have a look inside to get all the additional information. Before I jump into the initial market assessment report, just a small wrap-up. You've seen it already today. This is the Cafépla valorization route. So heterogeneous biowaste and green waste is converted into platform products. So those are those 2 platforms we heard about. It's the carboxylic acid platform that produces short-chain carboxylic acids, and the fiber recovery platform that produces fibers. And then they can be transformed into multiple products that you heard about already, which are the blue ones you see on the right side. And what we did at Decima is first look very detailed on those products and the markets in the first report, and then more general look into the platform, how can value be generated within the project, and then we also zoomed out and to see the impact, in the European bioeconomy, and they're more general also looking at bio-waste valorization. So for this initial report, as mentioned, we had those 4 products, and what you can find in the report is basically lots of data, market data, import-export data, but also a detailed description of the processes. So most of the products, not all of them, have conventional production routes, and we show like what is the current producing or who is producing them currently, what are manufacturers, describe the market, the prices, and also the growth rate. And also discuss a bit what is Cafépla offering, which solutions and which challenges do we see here. So if you want to see all those numbers, download the report. For now, I want to once again focus a bit on the products that we looked at. And so on the top left, you see the PHAs that were mentioned before, and they are provided within the project by Biotrend and Technalia. And we will have a separate talk about it later. Just to mention here what's important, depending on the content of the PHA, you can have very different materials. So it's really useful base material for the production of plastics, but also biocomposites, for example, as you see on the right side, where you see a mixture basically of fibers and PHAs. And here you can also fine-tune the properties depending on what you want to have. So you have a very broad market application. So in the domestic sector, but also the building sector or the automotive industry. And here we'll also hear about more later and actually see some, hopefully, outside. Then next would be the microbial protein, which is produced by Avicom. So this is a product coming from the carboxylic acid platform in a 3-step process. So it's a fermentation, then dewatering and drying process. And in the end, you will get a very protein-rich powder, which you see on the picture, which can be used in the feed industry or as feed additive, but also as slow-release fertilizer. And this was also what we focused on in this market assessment. And on the right side, you have caproic acid, which is a base chemical. So this is a chemical or a material with very broad application. So also in the energy sector, but also as feed additive or bioplasticizer. And it's produced by the University of Ghent. They have a dedicated fermentation process with a very high recovery rate, and I'm sure we will hear details about it later from Kevin. And then last but not least, there are many options for fiber valorization, and one you see on the left is with short fibers for the production of mortars, which can, for example, be used also in cement. And on the right side for long fibers, which for example can be used as insulation material. And FID is here today to present you how they generate these very valuable products that have also a very broad application, for example, in housing and insulation materials. Taken together, what we found in the initial market assessment, that for all the products I showed you, there's an increasing market demand, which is firstly, well, because of growing markets, but also because of environmental concerns. So all of the products had a very positive growth rate in the next years. What we found on the challenges side, so they all face, as mostly all bio-based products, the similar hurdles. So one is the price and one is the material properties. So they still have to compete with often fossil-based cheaper products with established routes and certain product properties. And the nice thing is that within Cafipla, all those hurdles are specifically targeted. So first, because we have this very abundant available feedstock, bio-waste, which is cheap and not competitive with food. And second, with all the processes you will see today, they actually generate materials with very advanced properties. So we can overcome this challenge and in the end have cost-competitive products. For the second report, I want to briefly touch on, it's the final market assessment. Here we zoomed out a bit again to look at the bigger picture. And it has 4 main sections. And first I will briefly talk about the first one, which is more general, putting bio-waste in the picture of a circular bioeconomy. And here we looked a lot into reports, statistics, European projects, and publications, all looking into this and provided a summary to actually show what bio-waste is used for. And what we can tell is that bio-waste is an essential feedstock in circular bioeconomy. And here I just want to highlight 2 reports, one from the European Environmental Agency, which actually highlights the importance of bio-waste in the transition to a circular economy, and then the Circularity Gap report. And both of them actually highlight, as you see on the right, that a key element of the circular economy is the utilization of waste as a resource. So I think everybody is aware of this by now. Then one report Thomas briefly mentioned on is this report talking about biomass availability. And as he mentioned, there will be a scarcity or not enough biomass to make everything we want. And this report says that in the future, there will be focus on material usage, so high-value products, and probably less on energy production. And they clearly mention fibers, but also chemicals, that they will be most important as products derived from biomass. And they also state that nearly all current petrochemical products can be replaced in theory. So also here, I think we can take that bio-waste can play an important role in mitigating this predicted gap. Something we heard about a bit in the previous talks is the amount of bio-waste. And also here we can say it's a very abundant and currently underused feedstock. So it's the largest single component in municipal solid waste in the European Union. And as you see in the graphics here, only a small part is currently treated by anaerobic digestion. And as we heard already from the city today, that there's still quite a part going to landfill or composted. And so this again highlights the importance of cities, that they actually treat the waste they have more carefully, or that we should help them to get more value out of them. And something we heard already, so landfilling is also having a very big impact on climate change. So also here, it's not only about generating new value, but also reducing emissions. And as we heard also before, there are quite some ambitious targets to cut those emissions, and landfilling was banned. And especially food waste has to be cut significantly by up to 50%. And last but not least, there are 2 more points I would like to touch on. One is, again, the city. So you see many European projects looking at this valorization at an urban space, which is because, as we also saw in the maps, it's all about the cities. So currently we have this take, make, waste linear economy, and all the waste is generated in cities, and so this is why we need solutions for the urban space. And second point is that we should be quick, because not only for climate, but if you look abroad, also especially America put up quite some heavy initiatives to promote bioeconomy, circular economy, but also China is stepping up. So also in Europe, we have to speed up to stay competitive. So here you have at least 7 reasons why biowaste is an essential feedstock in the circular bioeconomy. Then what we also looked into, what's the role of the pilot that you saw? So how can it actually demonstrate biowaste valorization in an urban area? And this is just 2 more pictures to sum up what the loop is. So it was installed in Belgium, and you've seen some pictures already, and it's TRL5. And it really demonstrates how this transition could be done, so how upscaling of biowaste utilization can look like. And also here you will hear more about it later. And there are actually different ways such a technology could be implemented. So it could also be a standalone to valorize waste, but what we also did within the project, which is currently most realistic, is that it's integrated in existing sites for waste treatment, which you can see here. So at the bottom, you see the current value chain of Idelux, how they treat their biowaste in Belgium. And at the top part, you see how such a technology can be integrated. So with the carboxylic acid platform and the fiber recovery platform to generate the platform products, which are then transported currently to the partners to generate end products. And also here we will have a very nice talk later. Last but not least, we worked on a so-called implementation guideline, and here we took one step back again to actually provide step-by-step guideline how to implement such a technology on an urban level, but also looked a lot into challenges, but also opportunities. And this data was mainly derived from stakeholder workshops that we also had with DBFZ, surveys, conferences, and which we summarized here. And the report will not only cover what was shown at the beginning, so how do I find my feedstock, what's the quality and the quantity, but also look a bit on the local level and also the legislative level, and also how you have to engage with stakeholders to actually get such a technology running and also to generate value out of it. And this is just one example from the guideline, where we describe in detail the steps of the first part, so how to find your feedstock and then how to engage with stakeholders to valorize them. And that's for now, so I put you the QR code here, so you can download the reports, and I hope they're valuable for you to learn more about biowaste, but also to utilize it. Thank you.
Yeah. Are there any questions to the market of bioproducts? No? Okay, then I would say thank you very much for the first round, so that we will move now to the more technology part, let's say. So if you want, you can then also sit down with the rest. I don't know, we will have now a presentation from Steph Denea. He is a business development expert, and he is promoting in the moment a European project, Tesh for Biowaste. Also the project finished already, and they made he will explain that more in detail, but an atlas or about valuable technologies, because of course the Cafibla technology is not the only one which is on the market or is developed. So there are different approaches which could be maybe combined or depending on the specific situation could be used. I don't know if Steph is already online because he's traveling, and in theory he should be already in Amsterdam on the airport and should be joining us online. He was fortunately traveling to Turkey, and he's now on the way back. So I don't know if is he already online valuable, or let's see. Because we are a little bit advanced, so I don't know if he had already time to looks like not. Yeah, okay, then. Yeah, then maybe we have to wait 1 minute or two. Is there maybe any more questions or whatever for the previous presentations? We could maybe already discuss some aspects. Okay, do you want to explain a little bit more, Susan? You want to?
Like if people want to have a look further on the dashboard,
Yeah. Okay. Okay. Yeah.
they can do it themselves.
Then I put the dashboard again there. Susanne, how is it going to to go, for example, if we could go directly to our region here, for example, or that could be interesting.
Would you like to see
Vitoria,
the biowaste?
Biowaste, yeah, biowaste. So
then we go to the smallest region, which is the local level. Can try to zoom in. Maybe I need your help to find. Here. Yeah, it's just like. It's just this region, maybe. Victoria, today. Let's have a look.
yeah, Alaba.
Yeah.
So
I mean, you can see here also, since 2016, the rate of bio-waste collection increased a lot. It's quite interesting, quite good. Although we saw there's still some room for increasement. And if I want to see how Victoria or Aleva is comparing to other regions in Europe, we see they're still quite far behind. I'm sorry. They're still quite far behind the others. So in the first is Rome. Of course, it's like the bigger cities have, because we see the total amount of bio-waste, and this is not now put in comparison with the actual population. So in the next step, we should also see how much bio-waste is collected per person, and then do the ranking. Because at the moment, like the biggest cities are of course on top, but this will be the next step. But nevertheless, this tool is also made, as I wanted to tell you, for policymakers or investors who want to apply this technology to understand where are actually regions to follow up a long-term strategy. So usually investors, or like if I want to make a political strategy, I really need to think like long-term, 10 years, 20 years. And there I see now which regions need maybe a bit more support. Especially we also see Eastern European countries. They have a lot to do to invest in new technologies to like come up. So you see if I zoom out, there's loads in France. Like here we see especially like these regions are really low yet in the collection of bio-waste and valorizing these waste. So it's very important also to focus to then catch up with the European laws, for example, coming up in like 2050, what we heard already. So this is the big value of maybe such a dashboard to really see where the hotspots, where I can invest, but also where there is a lot of investment lacking and where investment needs to be done.
Sarah, for example, for you, for the town hall, this is interesting, also to see, also, okay, your own numbers you have, but as you also stated that, you know, we should improve, but to see also how neighbor regions are advancing, or neighbor countries like France. This. Yes. No, it's also then to go to the politicians, which make later on then the decisions to say, look, this is what we want to do because we have.
Okay, some more questions to that or some more advices? Yes, please. Maria-Lene? Yeah, it's biowaste from municipalities. Oh, okay. Yeah, exactly. And then for the reactor that you put capacity plant, are we in green or not? I don't see it here. I mean, the separate collection has been installed since a very long time in the province of Luxembourg. We were really... Yeah, it's like whatever the province of Luxembourg is reporting to the European Union. Like, we took the statistic of the European Union, and whatever the province of Luxembourg is reporting, how much biowaste they are collecting, you can see here over the last years. I'm going to have a look at this. Yes. Because I know that we did this separate collection since a very long time, and to see if we are. Yeah, and we saw actually a lot like differences in the methods of how to report, how to calculate, and like also there could be a separation in green waste and biowaste, like there are different categories, but some countries just report in one or the other category. So that's why we took everything a bit together, because yeah, it depends on the reporting system, what you in the end see. That's what I mean, like we have seen a lot why data quality in the end, or what we see visualized, is not really what we expect, because it's already starting with the data collection and the methods how to collect. This needs to be harmonized in the first step to then really compare also better. And if you want to know more about the methods we used and like all the data coming from, you can ask me. We just published yesterday, or submitted a paper. It's not yet published. But if you want to know more, you can come to me and then I can share all this information with you.
Yeah, but it's an interesting point, because it's what we discussed also before for Vitoria. One thing is you can implement the selection scheme, but maybe it's not working so well as you expect, and maybe it has to be modified in a certain way to get more the people involved. I don't know really how it is then on the local level, Maria-Lene, how this is the collection is done. But here in Vitoria, the system existed, so biowaste collection exists also since years, but now it's modified to improve the quality, but also to improve the quantity, because we have seen that it is not, it's not enough to reach all the objectives in a certain way. Yeah.
That's the same everywhere. I mean, it's based on the citizen willing. We have no control of that, and the waste treatment plants, they just collect it as it is. We cannot say to people usually sort it well enough, so we let your rubbish in front of your home. Then the policymakers will not be happy, municipalities, because then they come back to us and say, okay, we are not the police for that. So yeah, it's based on that. And we, as waste treatment plants, try to invest money in new tools to sort better the waste when you arrive at the plant, because it's too late when you collect it. It's like it is. Nobody wants to sort it by hand, so we are more looking for new tools to sort it afterwards.
Yeah, but so there the connection, as it is circularity, it's not you are a waste treatment facility, no, it's between the municipalities, it's between the citizens, so there has to be also more communication, as it is a very critical aspect, I think, for to make it working, the circular bioeconomy.
Yeah, exactly. We need to make people aware of
in all these aspects of circularity, waste treatment, and so on. The people who are not interested will come to the plant to visit.
And I think we saw the same with the companies around the plant. No, many companies didn't really know what their waste, that their waste has a value, and then they could do something with it. And I think, yeah, a lot of awareness needs to be raised. I just got the numbers for Marchand Farmen. No, it's the right thing.
That's one municipality, I would say.
And I compared it with the neighboring districts. So you're the expert now to tell us if it's more or less right. But one thing is like that, of course, this region, as I said, the study area is a very rural region, which means also there's, compared to the rest of Europe or other more urban cities or urban areas, the amount is rather low. Nevertheless, the loop worked, and I think we can also build up a bigger production site. And if it works for a rural area, then I would say also like it should be very valuable to put it in a more urban area and to earn money with this technology, I think.
Yeah. I agree fully.
Okay.
Yeah. Yeah, no,
Okay, perfect.
I've seen it here below.
Then
So, thank you very much, Susanne, for explaining that more in detail. As we have here, that's very good. Now we will, as I said already, Steph Dinea will present us results of the Tech for Biowaste project. And as I said, he's a business development expert, and for that reason he's also traveling quite a lot. And he will introduce himself, and he will explain us also what is Tech for Biowaste about. Steph, you are on, it's your floor.
Yeah, thank you, Thomas. I suppose that everybody can hear me properly. Is that okay?
Yeah? We can hear you.
Yeah. Okay, yeah. So yes, indeed, I'm traveling a lot. Just arrived from Istanbul this morning, now at Schiphol, and then going to the World Biomarkets Conference later today in The Hague, in the Netherlands. But in the meanwhile, I would like to take some time to also talk to you about pilots for you, and especially today of Tech for Biowaste. So let's start with pilots for you, because why am I mentioning that? I'm in fact mostly busy with managing the Europe-wide network of pilots and demo facilities. So the open access pilot and demo facilities for the bioeconomy, that is called Pilots for You. That is today an existing platform and an existing network of open facilities. And that is also the reason why I am involved in the project of Tech for Biowaste, because this is also about a platform, a Europe-wide platform, not related to, let's say, facilities, but related to technologies and technology owners. And in fact, how did it start, Tech for Biowaste? Well, we are in full transition from the fossil-based industry to the bio-based economy. And there is a huge question about, will we have enough feedstock? And of course, there's a lot of feedstock, first generation agricultural streams, and also in the food industry side streams there. But we try to find new solutions, new applications for biowaste. So what we call the third generation feedstock, because it's abundantly available. And today, when we look at the use today, mainly the main use in Europe, we see that a lot of this material goes to biogas fermentation, so anaerobic digestion, and in fact producing biogas, having, let's say, green energy. That's very nice, but this green energy is then turned into in a thermal conversion to let's say 100% CO2, and that's not let's say the ideal solution for this carbon. We need to upcycle more this kind of waste. And yeah, then the question is, but where is this technology? Where can I find it in Europe? Because it's popping up everywhere. We don't have an overview. And I give you an example, a specific example, because I know it very well, because I'm also related to Biowaste Europe pilot plant in Ghent, in Belgium. And there they created last year a separate hall in this pilot facility, separately, the gray hall, they call it, to also be able to involve biowaste. So next to food grade processes on the other side of the plant, we have now a gray hall where we can transform biowaste into valuable products. And one of these products is, for example, biosurfactants. And so with the R&D ongoing there, they turn biowaste, kitchen waste, restaurant waste, supermarket waste into biosurfactants. So, and that will end into, you will see it in the coming months, a company mentioning we have a bottle of dishwasher product. The bottle is made out of a bioplastic and the content is made out of waste. And it's a biosurfactant because all these surfactants mostly are actually fossil-based and there's a huge demand for that. So that's what we call not a downcycling towards energy and then CO2, but more an upcycling towards products. And that's, to find that, you now have, and that was the ambition of Tech for Biowaste, is creating this overview nicely and in an open access database. So it was in 2020 a BBIGU call, and in this call they asked somebody to make this overview. That was partners BTG in the Netherlands, Nova Institute in Germany, and the Biowaste Europe pilot plant. They submitted together a proposal and started in April 2021 with creating this database. And I would like to propose to go to the first video of this project.
Finding emerging, innovative technologies was our line of work. And man, what a tough job it was. Tons of different types of bio-waste on one side, and a long wish list of bio-based end products on the other. And then us, in the middle, trying to connect these two worlds with emerging and innovative technologies. It took us long days, long nights, stress, and frustrations. We often asked ourselves, why? It was just too much.
We took the problem and we solved the problem. No problem. So we connected all the dots, put it together, and now we have the solution for everything.
With our database, it's very easy to find a new solution for your bio-wastes. You can find and compare new and emerging technologies.
We pulled them out of the misery, got them out of the dark.
It's a real treasure for everyone who's working in the bioeconomy. If you have a technology which is not yet in our database, get in touch with us. No time to bio-waste. Get your technology out of the dark.
As for us, we still have some dots to connect.
So that was our first video. Thank you, thank you. This was our first promotional video to attract, of course, attention of the technology owners. I would like to grab the moment now to go into the database and to show you how it works. So I will share my screen for that. So in fact, you go to techforbiowaste.eu. There you click on database, and then you come into this database area. And in fact, we have a lot of tutorial videos. Also on YouTube, you can find easily your way how to click and search in this database. It's a wiki media, it's a media wiki area. So, and in fact, we have a lot of features, but one of the interesting ones is the feedstock product matrix. So that's an interesting one because there we make, in fact, the connection between the products and the feedstock. So first you have some feedstocks, different side streams, and then you can turn them into different kind of products. And they are here listed in a sort of a cross table, so a matching table. So you can find technologies for specific groups of feedstocks and specific groups of products. And let's take the example of, for example, here, food-related waste streams, turning that into bulk chemicals. Well, you can see that we have different colors here, and we have enzymatic processes. So let's say biochemical processes. We have industrial fermentation. We have insect farming. And then in red, we have thermochemical processes, gasification, and thermochemical processing. And in blue, there is heterogeneous catalysis as a solution. So that's let's say the connection. We have more than 36 different technologies and more than 100 technology owners. But for example, if we would be interested in industrial fermentation for that part, you end up at the end of this page. And there you have the comparison tool. So in this page, you already see Cafipla members also present. And they are listed, and you can compare them into different columns. And then you have, let's say, different elements, different information about all these technology owners, one by one. And you have, this is an example company, Bluecon Biotech, with some information about the company, then technological details, in the middle, and then at the end, feedstock. What kind of feedstock do they use, do they process, and they turn it into what? Here it is into lactic acid, for example, polymer grade. And then we found some information about this company and their technology. And so you have all these, let's say, technology owners, but that is at the end of the page, because at the beginning of this page, industrial fermentation, you have a lot of information about what is industrial fermentation, what kind of feedstock is used, what kind of process is this, and then what kind of products come out of industrial fermentation. So that is, let's say, in a very short nutshell, how this database looks like and how you can search and click. Of course, there is also a search box at the top right side. So that was shortly that, and I would say let's go to the overview. We have made a short overview of all these technologies, and I would like to ask to start this second video. Thank you. you see in 3 minutes you have a short overview of all the companies present actually and still growing. Well, before we start with the next video, I would like to also refer to Pilots for You. When I started, I asked our members, can you please, because in this database, you have a lot of information, text, and some pictures and graphs and tables and schemes, but in fact, video material, visualizing the activity of the facilities, for example, of Pilots for You. I asked the members to send me their information, and yeah, that is really lacking. I speak about 3 years ago, but we did the same exercise now with these technology owners, and we try to visualize what they do. So in a sort of a short video of 2 minutes, we now assembled 20 technology owners, and you can now see what they are doing, and that is also helping, of course. I would like to ask to go to the third video. Thanks. So voila, this is the first visualization of Tech for Biowaste. And you probably also saw the pilot plant of Cafipla in it at Tenville, which was very nice to be also present there during your meeting. Yeah, let's close by saying that during last year and also beginning of this year, a lot of connections were made, populating the database. We finalized the project end of March of this year. We did a launch event at the end of the project, at the end of March. You can find all that on YouTube. So only type YouTube and then Tech for Biowaste. You can find all these video material there. For this last webinar, we had 450 people registered. So there was a huge interest. So we had a large outreach. That's nice. Everybody knows now what we do, what they can find. But now what? So what? That's the main question. How to proceed without funding? That's also a question, because now the project ended and the platform is ready and nicely filled. But how to proceed? And we already decided as consortium that leaving this as a standalone platform won't have enough traffic, so we would like to connect it. We are now connecting it, making interconnections with other related platforms, and integrate them in something bigger. That's in fact the ambition for the next coming period. But we still do promotion of, this is still ongoing. Today I'm doing promotion towards you, so I hope that we will have some additional people interested to add their technology information. If you are not present yet, of course, on the Tech for Biowaste platform. And I would like to also invite you, because we will still promote and interconnect, and you see it here. So I all invite you to come to Pitch Perfect and Boost, the European Bioeconomy event in September. It's a one-day event, which is a collaboration of different entities. One of these entities is, of course, Tech for Biowaste, so it's still alive, as you see here on the right side, but it is an interconnection of different ecosystems, different projects, different communities, and they all gather in Brussels for different kind of activities: pitching, matchmaking, networking, innovation scouting. So there will be a lot of investors present, technology owners, because there will be 99 pitches in total. Also matchmaking is going on the whole day. So that's a bit in short to, let's say, finalize my talk here. Thank you for the attention, the interest. Hope to see a lot of you the 25th of September in Brussels. And I will be ready to answer your questions after this last, let's say, launch video that we released end of March.
We took the problem and we solved the problem. No problem.
One crucial question remains. Is our technology database still in time to boost the further growth of bioeconomy innovation? It's a hell of a job to find and connect technology owners and bio-waste providers without a clear overview of what's happening in a quickly changing innovation ecosystem. A shadow world looms as things slowly spiral out of control. No time to bio-waste. We built a database and populated it with bio-waste conversion technologies and corresponding technology owners. Time to bring it out there now. To call database users to action. Time to matchmake technology owners with bio-waste providers. To get deals done. Out of the dark. The Tech for Biowaste database, available now to everyone for free. Check it out.
there questions for Steph? Because I have two already.
Okay.
Okay. So the first one is the technologies you have included in the database. Which technology readiness level do they need to be included in the database?
That's a good question, indeed. We start from TRL 4.
Okay. Okay.
So everything that is not connected to, let's say, the lab activity, proof of concept.
Which we create biogas from all sorts of organic waste. But we want to improve this technology because the dependence on non-renewable carbon resources is still very high. And innovation in this technology is a necessity because it will reduce greenhouse gas emissions more. It will creation of new sources of renewable energy, and it will reduce also waste disposal costs and create jobs with the implementation of this new pretreatment. I will go briefly over this Caféplat process flow because Esther and Thomas already highlighted it. But the carboxylic acid platform here in Caféplat is an important one because it serves as the building block for a lot of different applications. And that is why this is a key element in the Caféplat project. So how does it work, the short-chain carboxylic acid platform and the production of short-chain carboxylic acids? Here you can see the brief and overview of how anaerobic digestion works in the creation of biogas. So we start off with a complex matter that comes in. This is going to be our organic waste feedstock. And through hydrolysis, these complex matter is broken down into macromolecules such as sugars, amino acids, and fatty, long-chain fatty acids. And then these are further broken down using acidogenesis. And then we create the volatile fatty acids, as well as acidic acids and hydrogen and carbon dioxide. So in a normal biogas production, these free molecules that are created are further broken down, and eventually we create biogas through methane and carbon dioxide. But in the short-chain carboxylic acid production, we actually want to stop the process, so we don't want methanogenesis, we don't want acidogenesis, and we actually just want the volatile fatty acids. And by optimizing parameters, we create and produce these volatile fatty acids, and they remain inside the reactor. And that is a crucial pretreatment process step that serves as the basis for the carboxylic acid platform. So in this case, the short-chain carboxylic acid target molecules that we focus on in the Caféplat are acidic acid, propionic acid, and butyric acid. These are the three target molecules that we want to produce as much as we can from the organic waste as a feedstock. And the first thing we want to do is we want to try to identify the maximum short-chain carboxylic acid potential. How much can we produce out of a certain amount of organic waste? And this is being done by a batch test. And what it also serves is that we identify process parameters, so testing different pHs, testing different temperatures, and then we also can see what the spectrum is, so what type of short-chain carboxylic acid we can produce using set pH and set temperature. And this will serve as a basis for further upscaling of the short-chain carboxylic acid production. And here's an example. So as you can see, we start off with a lot of lactic acid in the first few days of this batch test. And the lactic acid and ethanol is built up with also some production of acidic acid, but that isn't much. But after day 2, day 3, and etc., you see that the butyric acid starts to form, And then after 7 days, you also see that caproic acid is also being formed. So, and you can also see that from day 7 to day 11, the COD, soluble COD is very consistent, but and also the spectrum of the short-chain carboxylic acid stays consistent. So that's an example of a batch test in which we can see that, okay, for this type of organic feedstock, we see that there is potential to create a lot of butyric acid with certain pH and certain temperature. So that is being done and to test all kinds of waste streams in order to identify what they could produce given set parameters. But this is a batch test, so this isn't being tested on a continuous scale. And that's why we need to, after that, we need to test these potential great organic feedstocks with a continuous lab test. And in these continuous lab tests, we identify and test the optimal parameters that we concluded in the batch test, and as well as test the retention times and the organic loading rate. These last two parameters are also very important with a perspective of upscaling and eventually designing and testing a pilot scale. So the test duration of this continuous lab test is a minimum of 30 weeks in which we try to test different retention times, different organic loading rates, as well as the pH and temperature. And then we also see, okay, how much can we produce with these certain parameters, and gain a lot of information that will serve as a basis for the upscaling to a pilot. So after that is done, we eventually scale up. We identified the optimal parameters, which we are going to use in the pilot, and we use the same input and output characteristics as being identified in the continuous test case, and as well as the same downstream processing steps. So in this case, and for this Kaffeeplau, we started from the biowaste that we identified as a great organic feedstock, and then we ferment it in the loop reactor, and then we press it and decant it, and eventually we get a good and rich carboxylic acid stream. So now a bit more about the pilot. So the pilot, the organic feedstock that we used was Idlex biowaste, which is very high in dry matter, and we wanted to keep the dry matter as high as possible in order to gain a lot of nutrients out of it, which we can then use to create a lot of short-chain carboxylic acids. So in this case, a conveyor belt and a feeding funnel was necessary in order to consistently feed the loop reactor, as you can see here at the first picture, where we load up the material and then at a steady pace it goes into the reactor on the left side, which you can see in the second picture. It falls in, and then it's being transported with the first conveyor screw, which will push it to the 2 silos, and beneath those 2 silos is a second conveyor screw that is perpendicular to the first one, and this second conveyor screw actually pushes it up the first silo, and then it's being homogeneously mixed through this creation of a loop, and in that way we mix the high dry matter content of the organic feedstock, and as well as ferment it and play with the different parameters that we set. Okay, so after fermenting is done, we established a good short-chain carboxylic acid production. We need to extract some content of the of the loop. We don't extract all of it, because then we start from nothing. We want to keep a certain set amount of it inside the reactor to maintain the right biomass, as well as so the biological process isn't disturbed. So we extract the output, in which was collected in a biobox, and then it is being transported to a top. And here, for this pressing step, we use the screw press technology, also because